Okay, today we're going to look at adding, subtracting rational expressions. And these are a little bit different than multiplying and dividing because the rules are different for adding and subtracting when you add and subtract fractions. So we have to be careful that we kind of separate those two concepts. So let's just do a couple easy fraction questions. So if we had 4/5 and we're trying to add 2/3, the rules for fractions are we can't add them unless they have the same denominator. So we need a common denominator. So what we'd have to do in this case is we'd have to times each fraction to make a common denominator. So if we have a 5 and a 3 for a denominator, our common denominator is going to be 15. So what we'll want to do then is, what do we times the first fraction by to get 15? We'd have to times it by 3. So we times top and bottom by 3. So 4/5 would change to 12/15. It's still the same fraction, we just tripled it to make it so that we'll have the same denominators. And then the second fraction, we'd have to times by 5 in order to get 15, so that'd give us 10/15. And then our last rule for adding fractions was, once the denominators are the same, we would simply add the tops, add the numerators. And once you add the tops, we'd get 22/15, and we're done. So basically, in this case, with just regular fractions, we'd simplify it and add the tops, and that's it. We could change it to a mixed fraction, but we won't worry about it because with algebra, we're not going to do that type of thing. Okay, let's do a negative one just to kind of make sure we're clear. So we got 3 and 6, and in this case, both of those, the lowest common denominator would be a 6. So we don't need to times 3 times 60 to 18 because 6 is already smaller number that both will divide into. So the second fraction would stay the same. The first fraction, we just have to times it by 2. So we get 4/6, and then our last step is subtract the tops. So that'd give us 3/6, and in this case, we can simplify that. We could reduce that fraction down to 1/2 because we divide top and bottom by 3. So the process that we're going to do for rational expressions now is basically the same thing. Our first step will be to change fractions to have a common denominator. So we're going to have to times each fraction by something in order to get a common denominator. And then the second step will be just like we did with regular numbers. We'll add or subtract, whatever the case is, the numerators. Okay, because that's what we just did on the last one, right? We changed the fractions, then we added the tops or subtracted the tops, whichever the case was. And then in the last example, we simplified, right? After we got 3/6, we could simplify that further. So we'll do the same thing. We'll simplify if possible. And then because we're dealing with rational expressions, the last step always for any kind of question is state your non-permissible values. And that's it. So for any kind of question, that's going to be the process. So it's basically the same as fractions, just we're going to be dealing with x's and stuff. And once we do that, our work is done. So let's try a couple examples. So let's do the first one here. Let's do x plus 4 divided by x, and we're going to add that to 2x minus 3 divided by x. So in this case, our common denominator is x. We already have both denominators being the same. So since they're the same, all we have to do then is add the tops. So we'd have x plus 4 as our first fraction, and we're going to add 2x minus 3. You can put brackets on. Sometimes that helps kind of keep them separate, but you don't need to. So if we add the two tops, we'd have 3x plus 1 divided by x. So that's our final answer, right? 4 minus 3 would give you plus 1. And then our non-permissible value would be, go back to the original always, so our denominator was just an x, that's a 0, our other one was just an x. So in any step along the way, we see that we just had an x on the bottom, so we'd have x is 0. Let's do another one where we have subtraction. So a basic kind of question again, except our denominators in this case is 3. They're both the same, so we don't have to do any changing. Our common denominator is good, so we'll have x plus 5, and we're subtracting 2x minus 3. So this is where it's good to kind of keep them separate in brackets, and if we do that, we can see that we have a subtracting, we're subtracting a whole second polynomial. So what you would have learned in the past, sometimes it's easier to change, instead of subtracting, change that to a plus, and then do the opposite signs. And then you won't forget about dealing with that minus, because that minus goes on both the 2x to make it negative 2x, and it goes on the minus 3 to make it a positive 3. So you just have to be careful about that subtraction part of the question. So once we've done that, we got x and minus 2x, which would give you negative 1x, and 5 plus 3 would give you 8 over 3, and because our denominators was a regular number like 3, we have no non-permissibils, so we're finished. Alright, let's try another one. Let's do one where our denominators aren't the same. Oops. Okay, so let's do x minus 3 over 2, and let's add that to 2x plus 5 over 4. So these ones, our denominators are 2 and 4, so we're going to see that we want to change our denominators to make them the same. So in this case, 2 will go into 4, so we can make our denominator 4. Our second fraction, you can see, doesn't change. So the only thing that we're going to have to do differently is times our first fraction by 2, and we want to times everything by 2, top and bottom. So when we do that, times the top, we'll get 2x minus 6. So now that they're added, or they're multiplied, we have the common denominator. Now we can just simply add up the tops. So 2x plus 2x is 4x, minus 6 plus 5 would be minus 1 over 4, and we're done. Our denominator is just a 4, so we have no non-permissibles. We're finished. Okay, so let's try one where the denominators are a little bit different. So let's do 3x plus 2 over 4, and we're going to add that to x squared minus 2x over x. So in this case, our denominators are quite a bit different. We've got a 4 and an x, so the only common thing we would get is if we do both 4 and x as your common denominator. So you can see the first fraction, we're going to need to times it by x. We've got the 4, we're just missing the x, so we'll times that one by x. So we would have 3x squared plus 2x on the top. And the second fraction, we got the x already, so we just need to times it by 4. So when we do that one, we get 4x squared minus 8x. When we multiply that out, so now we're got our common denominators, we're good to go. So our final step is to add the tops. So 3x squared plus 4x squared would be 7x squared. 2x minus 8x would be 6x. We've now combined it. We're done. Except if we go back to the steps, our third step was simplify if possible. So in this case, we can actually common factor out an x on the top once we're done simplifying. So we have x on the top, a 4x on the bottom, so we can actually cancel that x out of both. So our very final answer then should be just 7x minus 6 over 4. Go back to the original question. We have a 4 on the bottom, so that's good, but we also had an x on the bottom, so our non-permissible would be a 0. And we're done. So that's it for that. So those kind of questions, pretty basic. Just make sure you change each fraction to have the same denominators, and you're good to go. The next type we're going to look at is what happens if the denominators aren't easy to switch. So let's do a quick example where we have 3x plus 2 over x squared plus x, and we're going to add that to 2x squared plus 2x. Okay? So if you look at this one, the denominators are similar, but we can't simply just do them both because we have a plus and a minus going on. So when your denominator isn't just a simple one-term thing like an x or a 2 or a 5x or something like that, what you want to do first, so now our new first step is we want to factor the denominators first. Okay, so if you factor the denominators first, then the rest of it will be the same. Then we want to do common denominators, add the tops, simplify. So after that, it becomes the same kind of question. So the first step then in this case is we want to factor our denominators. So we'll have 3x plus 2 on the top, stays the same. The bottom, we can just take out a common factor of x. So the first one we'll take out a common factor of an x. The second one we can take out a common factor of a 2x. So on the bottom we can take out a 2x, and we have x plus 1. So now when you look at these, we actually see that we have almost the same thing on the bottom. So the first one had an x and an x plus 1, so we need to have that as our common denominator. And the second one has a 2 times x plus 1. So we actually just need the 2. That's the only thing that's missing on the first fraction. So our change will be, we just got to times that first fraction by 2, and then it'll become the same thing. So if we times that one by 2, we'll get 6x plus 4 on the top, and our second fraction will stay the same. So now we can combine our tops, so 6x plus 5x will be 11x, plus 4 minus 4 is 0, so that cancels. And we have 2x times x plus 1 on the bottom. And we're done combining them, so now the last step is, can we do any simplifying? And once again, we have an x that's the same top and bottom. We can actually cancel those out. So then our final step, our final answer would be just 11 over 2 times x plus 1. And our non-permissibles are, if you go back to before we did the canceling, we have the x by itself, so that would be a 0. And we have an x plus 1, so that would be minus 1. Okay, so the harder type questions, that's really the only thing that changes, is you might have to do the factoring first. So let's do one more that's a little bit more complicated. Okay, so let's do 4 over x squared plus 4x. And let's add 3 over x squared minus 3x. So it's similar to the last one, just a little bit different. And then we'll do maybe one more after this as well. So when we factor that first one, we can take out an x on the bottom, so we have x plus 4. Factor the second one, we can take out an x again, so we have x minus 3. So now in this case, our common denominator will be x and x plus 4. We got that for the first fraction. The second one was x and x minus 3. So we just need to make sure we represent each factor once. We have the x plus 4, and the x minus 3 for both fractions. So for each of our fractions, we just have to multiply. So the top one, we've got the x and x plus 4, so we need to multiply by x minus 3. So that'd be 4x, 4 times x, and 4 times minus 3. And then our second one, we just need the x plus 4. So when we multiply those, we'd have 3x plus 12. So our final answer then is 7x minus 1 over our common denominator. And do our non-permissible values, 0, minus 4, and 3. And that's it.